Hi viewers. So in this video, I'm gonna talk about daemon sets in Kubernetes. So what is a daemon set? So daemon set is a Kubernetes construct that allows exactly one instance of a pod running in each of its cluster. So it's a type of a special case of replica sets that we have looked before, but there can be situations where you might want a particular pod to run only one pod in each of the Kubernetes worker nodes. So that can be a reason to have daemon sets. For example, you may have a situation where you have a resource monitoring pod to run on each of the node to monitor the node, of course. So in that case, there is no reason for the application to run multiple pods of that monitoring pod to run on a particular node and so forth. So that can be one reason to have daemon sets in place. So another example, if you can, even in the Kubernetes internals itself, the kube proxy process has exactly one pod running in each of the worker nodes. So that's a special case in the Kubernetes world, but in the application side as well, you can have situations where you might want to run one single pod in each of the node. But there can also be other special cases within that. You might want to exclude certain nodes on running this particular pod and so forth. So, daemon sets help do or help achieve this task in the Kubernetes cluster world. So let's have a look at this to start with. So I have this daemon set concept and this YAML file. Basically, it just brings up my container. This is nothing to do with application monitor or anything like that. It's just for the demonstration purpose, just another container. And so just like the replica sets itself, you have a match label and a label that attaches to that daemon set pod that belongs to that daemon set, so that if you by chance change the label, it will make sure it will run again and so forth. All that is applicable and so forth. Now, what's the difference between daemon set and replica sets is that it will daemon set will not randomly scatter your pods across your Kubernetes cluster, having two pods in one node running, no pods in another node, and so forth. It will exactly make sure one pod will always run in all those nodes that you specify. Most of the time, all of the nodes in the worker nodes in your cluster and so forth. And yeah, so that's the difference. And in case if you lose one of your node, there is no concept such as in replica set to bring that pod up, because that particular pod in the daemon set belongs to that node. So if that node goes away, then you don't have to replace that node. Kubernetes cluster doesn't have to do that. And if you let's say add a new node, of course in that case the Kubernetes will make sure that this particular pod that belongs to the daemon set brings or comes up in that particular node as well. And one important aspect of daemon set is that it's not controlled by the Kubernetes scheduler, because Kubernetes scheduler is the one that is responsible to schedule your pods into relevant nodes and so forth. Here in this case, it doesn't have to do that, so that it doesn't belong to the scheduler. So let's have this particular daemon set running. So I have this file already in place here called Flask daemon set. So let's have a look at that. As you can see, it's exactly what it what you can see from the right side as well. So let's create this daemon set now. And of course, you have to make sure that your Kubernetes cluster is up and running. I'm doing this demonstration in my local machine on Minikube, so it's a single node cluster. So we won't be able to see this pod running in multiple instances and so forth. So, but still, we can see something up and running here. So Flask daemon. So let's apply this, and this should create the daemon set here. So of course, as in other commands, to get the daemon set, you can say get ds. For replica set, you just put rs. For daemon set, you put ds. And as you can see, desired state is 1 and 1 is available already. And you can also get the pods for this. Of course, you should see one pod running, as you can see. If I delete this pod, of course, you should be able to, uh, if I delete this pod, that pod should come up again, because the Kubernetes, we have to make sure this particular pod is running in each of the worker nodes, at least, not at least, actually, exactly one pod running and so forth. Let's try to see what happens. So let's delete this pod. And if I delete this pod, immediately it creates one back again, right? As it should, right? So you do that. And next we can also delete the entire daemon set. And if I delete the entire daemon set, the entire thing is gone. Of course, now I mentioned previously, so let's start our look at this. So under the spec section, we have these containers, but under the spec section, you can also have something called a node selector. A section called node selector. Under that, you can specify few labels, such as let's say network, SSD, or whatever, something like that, right? So which selectively identifies which nodes this daemon set should be applicable for. That means only on those nodes that has that particular label applicable, that's where the daemon set will apply its pods on. So that's for the case where you don't want this pod to be running in all the nodes, but on specific nodes. It might be a situation, there might be a situation where you have a particular hardware configuration, such as an SSD drive in certain nodes, a non-SSD drive in other nodes. So then you want to make sure this particular monitoring process is only applicable for those nodes that has an SSD drive. Then you have to make sure that it's running on only those nodes and not on other nodes and so forth. So that's exactly the daemon set is for. And yeah, it's a very short video, and I hope you got some idea of daemon sets on this. So I'll see you in another video very soon. Thank you for watching.